Sorry I'm not there today. Today we're going to do parabolas, but before that, I thought we would do one question from yesterday's work dealing with circles. So here's a circle problem. I know it's a circle problem because there are two quadratic terms, and they're both the same value. They're both 4s. So I'm going to put the x's in one parenthesis and the y's in a second parenthesis, and to move this 9 to the other side. See, I got to factor the 4 out. And then now we got to go ahead and complete the square. Half of 3 is 3 halves, and squared is 9/4. But when I multiply that by 4, it turns out to just be 9. Half of -5 is -5 halves. -5 halves squared is 25/4. But again, when I multiply it by 4, 4 cancels out. We're left with 25. So we've got 4 times x plus 3 halves squared. Let's see, 9 and 9 is 18, and 25 is 43. Okay, so now what we'll do is we'll divide both sides by 4 to get rid of those 4's, and we will have it in the right format. The center of the circle is at -3 halves, comma 5 halves. And the radius, well, it's the square root of this. So it'd be the square root of 43 over the square root of 4, which is 2. And that's kind of what you had done yesterday. Today, we're going to do our work with parabolas. So first, a little recap like we did before with parabolas, which was to, cage in the x's and complete the square on that. And write out our problem. All right, we can say that the vertex is that the x value has to be at -3, so the other value is a -1. And there's our vertex. And then I would use my odd numbers. And then up 3. And up 5. And there's our parabola, right? Now the thing is, most parabolas are not this sharp, right? Parabolas are the most useful parabolas are the ones that are really wide like this, like a lens. I think if you go into Mr. Kiter's room, you'll see a couple parabolic mirrors on the back wall that he uses to light people's hair on fire, probably. I don't know what he does in there. But what we need to do is discuss the definition of what a parabola really is, okay? Parabola is the collection of all points that are equidistant from a focus and a directrix. So everything on this blue line is on the parabola. So like this point right here is on the parabola. It is equally distant to a directrix, which is a line, and the focus. Here's another point that's on the parabola. It also is equally distant from the focus and the directrix. There's a very special point here called the vertex. The vertex is so special because, again, it is equally distant from the focus to the directrix, but that distance is going to be called the variable p. And that's going to help us find the focus, okay? So p is the distance between the focus and the vertex, or the vertex and the directrix. And there's something else also, the focal distance. The focal distance is if you go from one side of the parabola to the other, going through, right, parallel to the directrix down here, this is called the focal distance, right? Parallel to the directrix, going through the focus. Okay. So why do we care about parabolas? Why do we define them this way? The other way was just fine. Well, the focus is everything. Parabolas are probably one of the most useful conic sections we have out there. You wouldn't be able to have your cell phones working, or the internet, or cable TV without things called a parabolic dish, where signals come in from outer space, and when they hit the dish, they bounce. And the property of parabolas is that when they bounce off the dish, they all bounce off to one spot called a focus, right? So we want to locate the focus. And that allows us to pick up the signal of these satellite dishes. Your car headlight works in reverse. We put the light bulb at the focus, and when the light hits the silver arced portion, the parabolic portion of your headlight, it makes all the light go straight out in front of you. And that's really a useful property. We want all the light from our car headlights to go right out in front. Flashlights have this property, all kinds of things. If you watch football games, you'll see these people on the sidelines. And again, this is a parabola. Sound waves come in and hit the acrylic and bounce off to a microphone in there that's picking up, and they can hear what everyone is saying from super, super, super far away. So finding the focus, it's really important. I mean, yes, we can do parabolas like this, no problem, but the ones that are useful are the ones that are really wide, right? And when it's a really wide parabola, that means we're going to have a fraction on it, okay? It's no big deal. We need to look at two slightly new equations. They're very similar to the ones we have been doing. This is x squared, and so it's going to be a parabola opening up. This is y squared. It'll be a parabola opening sideways. What's different about these is they have this 4p in front of it. And remember, p is the distance from the focus to the vertex, this distance here. So having this value p in the formula is going to be really helpful for us to do that. Well, how do we go about doing these things? Well, we do like keeping the x's on one side, notice, and the y's on the other. So I think what I'm going to do is I'm going to move this positive 1 to the other side. And then we're really not a big fan of that fraction. So what if I were to multiply everything by 8? That would get rid of the fraction, wouldn't it? And then that would also allow me to complete the square. And we're left with 8y plus 8 is equal to x plus 4 quantity squared. Now you notice, but we got to factor that 8 out also. Notice these problems have a 4p in front. That's where this 8 is. So I think it's got to be 4 times 2. 4 times 2 would make an 8. Well, we've got it. The vertex is at the x value is a -4, the y value is a -1. So -4, -1, there's our vertex. 2 is the p-value. And we know that this parabola is opening up because it is an x squared parabola. So if I count a distance of 2 below, that would give me the directrix, which is x equals -3. Right, count a 2 below. And if I count 2 above, it will give me the focus. Focus is at -4, +1. And so our parabola will be doing something like that. Not too bad. Okay, let's look at another one. So pause it if you need to write some stuff down. All right, another fraction, but this time it's a y squared, right? But we're still going to go through the same process that we did before. We're going to move this -5 to the other side. And then we are going to multiply everything by 3 to get rid of that fraction. And then we will go ahead and complete the square. Factor our 12 out. And then again, remember, this part here has to be 4p. So 4 times, I think 4 times 3 is 12. There we have it. The vertex is at x is -2. The y value is -3. We know we are opening sideways because this is a y squared. And again, the p-value is 3, so again, that's our vertex. So if I count 3 spots to the right, I'll be at the focus. 3 spots to the left, I'll be at the directrix. So the directrix is going to be x equals -5. The focus is at +1, -3, and our parabola is going to be doing something like that. But what we're concerned with really on all these problems today is getting the right format, figuring out the focus and the directrix. The sketch is just to kind of help us see what the heck we're doing. So homework, you have to do some of those, and then you'll have to do these interesting ones. So I'm going to give you not everything. I'm going to give you some information here. And with this information, you should be able to figure out everything you need. And I've got a little graph on the left. So I know the vertex is at 4, -3. So 4, -3, that is our vertex. The directrix is x equals 8. Now, if I see that, that should tip me off that the parabola has to be doing something like this, right? Because the vertex is always on the, no, it's not doing something like that. What am I doing? The parabola must be doing something like this, right? Because we're not going to cross over the vertex on that. Well, we got to find the p-value. Well, again, the p-value is the distance from the vertex to the directrix, and that's a 1, 2, 3, 4. Our p-value is 4. That's just about enough space to figure out the standard form of our equation. It's, let's see, the y value, it's, our vertex is this, so I know it's y plus 3 squared, right, because it's sideways. And there should be a negative in front of that because we're going to the left sideways, equals, now our x value is a 4, so x minus 4. But again, in front of it, we've got to have 4 times p, right? So it'll be 4 times 4. Or if I want to write it out nicely, okay. Now, the focus, we do need to find that also. The focus, I move a distance of 4 to get to it. 1, 2, 3, 4. There's our focus. Focus is at 0, -3. So this is pretty quick, right? We're not completing the square or anything. We're kind of giving some puzzle pieces, trying to solve the problem of what's going on here. But the key is to draw the stupid picture so that we can kind of see what's going on. Okay, pause it if you need to look at it. Otherwise, we're moving on to the next one. Okay, here's another one. This time, we're not told the vertex, but we're told the focus and the directrix. Now, the focus is at 0, -3. And so that's our focus. And the directrix is y equals -9, which is down here. Well, that means that the parabola must be, going like this. And the focus is always on the inside of there. Let's see, this distance is 6 between there. So I think if I want right here, that would make sure that that distance is 3. And so, yeah, that would make it work out just fine. Well, wow, hey, there's a vertex right there. And the p-value is 3. Vertex is 0, -6. It's vertical, right? So it's, let's see, x minus 0 squared equals 4 times the p-value times y minus, or y plus 6. Not too bad. Again, the sketch really helps us out to see what's going on. And it doesn't have to be on graph paper. But when you're doing the assignment, I would strongly encourage you to do a sketch to kind of make sure things are going right. All right, last one. Vertex is -3, 1. And the focus is -1, 1. That's our focus. Well, if this is the vertex, now I think by looking at this picture, we know we've got to be going sideways, right? Because the focus has to be inside of the parabola. So we'll be at a y minus 1 quantity squared equals 4 times, got to figure out that p-value in a second, x plus 3. Well, again, the p-value is the distance from the focus to the vertex, and it looks like that is a distance of 2. And the directrix would be a distance of 2 as well out here. And that's the equation, x equals -5. Okay, so that's not too bad. Sorry I'm not there today. And then I'm also gone tomorrow because of a math department chair meeting. So I'll be here on Thursday morning. Come by and get some seminar passes if you want to see me. And I'll be here Friday also. Okay, have a great day.